welcome to today's lesson, the complex machine. And today our primary focus will be to investigate what a complex machine is by deconstructing the bicycle. Okay, so today's objectives are we're going to be able to describe the overall function of a device. So in today's lesson, what is the overall function of a bicycle? Number two, describe the contribution of each subsystem or component to the overall function of the device. So we'll break down the bike into its subsystems, identify them, talk about what simple machines they are, which leads us into our third objective, identify components that act as simple machines. So we'll do that for a bike. We'll break down into the subsystems, and then we'll talk about what type of simple machine are they, and how do they function so that the overall function of the bicycle is completed. And then the last one, identify the source of energy for some familiar mechanical device, and we'll look at the bicycle today. I would imagine some of these are fairly obvious, but some of them won't be so obvious, or they'll be obvious as to what your subsystem is, but you may not realize what kind of simple machine it is made up of. Okay, so that's what our focus is today. Okay, so the complex machine, as civilization developed and people started beginning living in larger communities, they needed ways to to build larger buildings, provide running water, and develop transportation systems for moving people and goods. And so their needs became more complex. The machines, in order to achieve those problems or to overcome those problems, became more complex as well. And so here we should start off with a simple definition of what a complex machine is a system in which simple machines all work together, so unified in the task that they are to achieve. And a system is a group of parts that work together to perform a function. So really, when we talk about a system, complex machine, you can almost use them interchangeably. And today, as I mentioned earlier, we are going to look at this in regards to bikes. We're going to look at a bicycle. We'll deconstruct a bicycle into its component parts. Okay, so within a bicycle are groups of parts that perform specific functions. And I'm not going to get into what those are right at this moment, but what you need to know is that those groups of parts are called subsystems. And so a subsystem in a complex machine has just one function. And a subsystem usually, but not always, contains a simple machine. And all the subsystems work together to complete the overall task or the function of the complex machine. So the bicycle, I think we would argue that the ultimate function of a bicycle is to get us from point A to B, although if you were really into cycling, you would know that there's different types of bicycles. There's bicycles for mountain biking, there's road bikes, there's kind of a general all-purpose just bike for casual use. There's tricycles, you name it. So yes, they have a lot of the subsystems will be the same in these devices, but they will have different designs and different features that make them better suited to perform the tasks that they're intended. All right, now let's take a look at the subsystems on our bike here. And the first one I want to talk about today is the handlebars. Handlebar's main function is to turn the front wheel. It is made of a wheel and axle that you see there at the pivot point, and it acts as a direction changer. And then you can see here it's connected to the tire, which is also another subsystem here, which is a wheel and an axle as well. Okay, the next subsystem I'd like to show you here is the braking system here. And you can see here that the braking system is made up of a lever. Okay, a lever in this case is a force multiplier, and it's connected by this cable all the way down to your brakes. Your brake pad is down by the tires here, and this is a disc brake system. But whether it's a disc brake system or a traditional system, the system itself works basically the same way, is to stop the bicycle. The hub here applies pressure to the disc, and then the disc with frictional forces stops the bike. The pedals are another subsystem. It allows the user to input energy into the bicycle. And as you can see here, it is a simple machine. It is a lever, a force multiplier. As well, you can see here the gears. The gears function to increase the speed in high gears or to decrease the need of input force in lower gears. Okay, and the last subsystem we'll talk about is the chain. The function of the chain is to connect the pedal gears to the rear wheel gears. It is a linkage or a transmission, and it transfers energy from the pedals to the rear axle. And if we talk a little bit more about the gears here, you'll see that there are many different gears on the rear axle. And as part of investigations that we'll do today, we'll investigate what that does for the advantage. Is it a speed advantage or is it a power advantage? All right, and just to summarize, the subsystems include the handlebars, which are not on the screen right now, but the handlebars here function to turn the front wheel. They are a simple machine, the wheel and axle with the wheel and axle part right at the top there. Okay. The second subsystem would be the brakes. The brakes use a lever to increase the force you apply with your hands to the disc brakes down below, or in this case on this bike, you got brake pads right up here by the rim of the tire. The wheel and axle, of course, is a system to allow the bike to move. Okay, and it's a simple force multiplier. Okay, it makes the ease of movement much easier. The pedals act as a lever, increasing the force you can apply to the wheel and axle. So the pedals, this is the lever here. Where your foot sits is the one part. This is the effort. And then you have the fulcrum, which is over here. And then on the inside is where the effort is. The effort is going on the sprocket here. Okay. And then, of course, talk about the chain. The chain transfers force from the pedals to the gears. So that's your linkage or your transmission. Okay, very important. The gears, very important as well, reduce the force that you need to apply, or they can increase the force that you apply, but for a speed advantage. So we'll talk more about mechanical advantage in the future, but yes, the gears are very important, and learning how to ride a bike using your gears properly is a pretty important thing to learn. Okay, it can make getting up that very steep hill a lot easier to do if you're in the right gear, to be in a low gear. And when you want to beat your friend in a straightaway race, you want to be in the highest gear possible. And of course, everything in between. And quite often when I'm cycling, I've learned over the years that I want to go into lower gears so that when I come into let's say a crosswalk or a place where I need to stop, maybe it's a set of lights, I go down to a lower gear so that I can accelerate fast as soon as the light changes, and I simply go to higher and higher gears as I increase speed. If I were to just start in high gear right away, I wouldn't be able to accelerate near as fast, and it would be more effort to get started. Okay. So now on to our tasks for today. Is a give it a try activity out of your textbook on page 271, and it's analyzing a mechanical device. So now that we've looked at deconstructing a bicycle into its subsystems and identifying what the subsystems are and what kind of simple machines that they're comprised of, now we need to look at a different device. So the device that I've given to you in this activity is a pencil sharpener, but you can use whatever device you want to at home, or if you happen to be in a classroom, you can use something in the classroom as well. So what you're going to do with a partner or by yourself is you're going to look at this device and you're number one, what is the overall function of the device? Okay, so with the bicycle, it's a method of transportation. Number two, how many individual subsystems can you identify in the device? And then describe how each one contributes to the device's function. So we could talk about the bicycle here. I would say, oh, the let's say the handlebars. The handlebars overall function, the simple machine is wheel and axle. And the function of that is to change the direction that the bike is heading. Okay, we could talk about the pedals. Okay, the pedals are a type of lever, and that is to transfer power from your foot to the drive shaft or the gears that are part of your front assembly. Okay, and do that for the device you've chosen, and I would expect at least two. So in order for a complex machine to be a complex machine, or not to be a simple machine, it's got to be made up of two or more simple machines. So you have to bare minimum identify two subsystems, and then for number three, do any of these subsystems contain a simple machine? If so, describe them. So for example, I was talking about the pedals. Well, the pedal is a type of lever, and you would I would identify that as a first class lever, with the fulcrum being where the pedal attaches to the bike frame, if you will. Okay, so um, either way, you guys can use your judgment on what they are. There are right and wrong answers, but even if you're incorrect, it's the discussion that's the more important thing when we give you feedback on this activity. Okay, so by now at this point here, you should be able to describe the overall function of a device. Specifically, you should be able to do it for bicycle and of one other device by the end of the day. Describe the contribution of each subsystem or component to the overall function of that device. Identify components that act as simple machines, and then identify the source of energy for some familiar mechanical device. And so coming back to the bicycle, it is human powered. So we transfer energy and force into the bicycle through pedaling on the pedals. But if you happen to be talking about a device at home, maybe you decided to talk about a motorcycle, which would have much more complex subsystems, but ultimately a lot of them would be very similar. You could identify the source of energy for a motorcycle as gasoline or chemical energy. So, all right, you guys, don't forget to hand in your assignments when you're done today, and we'll see you tomorrow. Have a great day, guys. Take care.